Hello everyone, how's it going? I hope you are as fit as a fiddle. Welcome to this video. This is the video part number 9 from the test-driven development video series, and if you didn't watch previous videos, you should watch this video playlist from part 0 one by one. I've put the link of this video playlist at bottom of this video in the comment section. Okay, you can watch all of this video series through this link. Alright, what's on the agenda in this video? Same as the last video, today we are going to complete the Soundex class implementation through test-driven development. But before that, don't forget to check out the session 9 branch. Okay, open up the Visual Studio Code. And don't forget to pull the repository, pull new changes. Okay. And on a status bar, click branch button and then session 9. Okay. In the last video, we have implemented a test case for case consideration. I mean this test case, uppercase's first letter. And it leads us to revisit the ignores vowel-like letters. As we have learned earlier, we expect that our code ignores uppercase vowels just like it ignores lowercase vowels. But we would like to make sure. We can update the test, this test case, to verify our concern. Okay, let's do it. We can add another same letter, A, uppercase, and we can add an E at this point, and then an O, uppercase, and then a U and H, also Y, uppercase. Okay, and it should return the same result. Okay, let's run test case. Alright, it passes. We could choose to discard our updated test, but in this case, we decide to return the modified test in order to explicitly document the behavior for other developers. Okay, now it turns to refactor. Let's open up Soundex class implementation. The code in encoded digits function appears a little bit implicit and difficult to follow. I think we should refactor it. First of all, many letters don't have corresponding encoding. And encoded digit function returns the empty string for these letters. And at this point, concatenating an empty string to the encoding variable it does nothing. Okay, I think we should make it more explicit. Okay, how can we do that? First, we can change encoded digit function. It could return a constant name, not a digit, when the encoding's map contains no entry for a digit. Okay, let's do it. We can define a new constant, const std, a string, not a digit. And we can set it to a string. Okay, and then encoded digit function could return not a digit when it couldn't find encoding in the map. And then we could add a conditional expression in encoded digits to explicitly indicate that not a digit encodings get ignored. Okay, let's do it. We can declare a new variable at this point, and then we can move this expression to this point. Then we can replace digit with this expression also at this point. We should also add another check to make sure the digit is not a digit. We should also alter last digit function to use the same constant. Last digit. If encoding is empty, it should return not a digit. Alright, we're done. Let's run test cases again. All of the test cases are passed. Also, we should add another test case that deals with the casing of consonant. Okay, let's do it. Open up Soundex test file, new test case, test F macro, Soundex encoding. Should ignores case when encoding consonants. We need an assertion. We can copy the previous one. Let's give it a new input. We can give it B, C, D, L. All of the words are uppercase. It should equal with return of Soundex encode when we give it B, C, D, L. Okay, in this new test, our assertion has a slightly different form. Actually, it's more declarative. It declares that the encoding of B, C, D, L, all uppercase, should be equivalent to the encoding of B, C, D, L, that all are lowercase, but except the first letter. In other words, in this assertion, we don't care what the actual encoding is. We just care the uppercase input resolve to the same encoding as the corresponding lowercase input. Okay, let's run test case to make sure it's failed. Alright, the new test case is failed. The next step, get it to pass. Okay, how can we pass this test case? I think in encoded digit function we could lowercase the letter when querying the encoding's lookup table. Alright, same as upper function, let's define a new function which is called lower. The output should be char and it should get a char like upper. We can use std to lower function. Same as to upper, we should convert the input to unsigned char as a sand.set, and we should also do it through a static cast. Sorry. Okay, and we can call the lower function at this point in line 22. Okay, we are done. Let's run test cases to make sure it's passed. Alright, all of the test cases are passed. Okay, back to the specification to think about a new test case. Rule number 3. Take a look at the second part. If you remember, in the last video we were trying to write a test to handle the scenario where the second letter duplicates the first letter, and that triggered us to make our algorithm case insensitive. Okay, we can now return to it and write this test case. Let's do it. Add a new test case, test f macro Soundex encoding should combine duplicate code when second letter duplicates first. Okay, we need an assertion. We can copy the previous one and we should pass a new input B, B, C, D, and it should equal with B230. Okay, let's run the test case to make sure it's failed. Alright, the new test case is failed. The next step, let's pass this test case. To pass this test case, we should change the policy embodied in encode function. I think we should pass the entire vote instead of tail of vote to encode the digits for encoding, because we could compare the encoding of the second letter to the first in encoded digits function, and then we can append only tail of the vote to the overall encoding. Okay, let's update encoded digits function. In encoded digit function, we should encode the vote's first character so that comparisons to the prior digit can compare against it. Okay, let's do it. Encoding and encode first letter of the vote. Okay, since encoded digits function now encodes the entire vote, we should also change its complete function, I mean this function, to consider one more character. We can remove this part, the minus one. Okay, back to encoded digit function. We should also change the core loop in encoded digit. To iterate across the tail of the vote. Alright, let's run the test case to make sure it's passed. Alright, it's passed. The next step, refactor the design. Okay, we can refactor encoded digits function. This function becomes more complex and actually it violates the single responsibility principle. Okay, what is the single responsibility principle? Actually, this principle, I mean single responsibility principle, or SRP, tells us that each function should have one reason to change. And in this function, encoded digits function mixes high-level policy with implementation detail. Actually, it has two steps. The first step is append the encoded first letter to the encoding, and then the second step, iterate through the rest of the letters and append them. And the problem is that encoded digits also includes the low-level details to accomplish these two steps. Encoded digits function violates SRP because it must change for two reasons. The first reason is if we want to alter implementation details, or the second reason if we need to change the overall policy for encoding. Okay, what should we do? We should extract these two steps from encoded digits into two separate functions, and each function containing implementation details for a simple abstract concept. And what remains in encoded digits declares our solutions policy. Okay, let's do it. We can implement a function for first step, which is called encode head. It should take to a string reference, encoding and also word. You can also make this function const function. And now we can move this part, I mean the first step, this expression, to this function. Okay, what's wrong? Encoded digits, it's not a const function. We could also turn this function, encoded digit function, to a const function. It also has another function lower, which is not a const function. We can also turn it to a const function. Okay. We should also declare another function for the second step. Encode tail, same as previous function. And we can move this part to this function. Alright, there is also another problem. Okay, you should also turn the last digit function to a const function, and also is complete. Okay, it's a const function. Okay, now we can call these functions at this point. And then encode tail. Now it's better, but we can also refactor more. We can go one step further and extract some of the body of the for loop in encode tail. We could also move this part to another function. Let's implement this function. I'm gonna name it encode letter. Now we can move this part to this function. Correct. And now we can call this function in encode tail. Sorry. Okay, we are done. Let's run test cases to make sure All of them are passed. Okay, we are done. That's all we have time for this video. In the next video, we will try to complete the Soundex algorithm implementation through TDD. I hope you enjoyed it. Thanks for watching us. See you soon.